Hello friends, welcome to my channel. Our today's topic is type of lines in drawings. Friends, it's a very important topic for everybody, for mechanical engineer, QA, QC, welding engineer. So it's a very important topic, and with the help of this topic you will be able to understand the significance and importance of the different types of lines which are given in the drawings. So friends, before starting this video, let me introduce you to myself. My name is Sandeep Anand. I am a mechanical engineer and I am having 14 plus years of working experience. Friends, I am having a hobby of sharing my knowledge, and I share my knowledge through my website, that is www.weldingandandt.com, and the second mode through which I share my knowledge is my YouTube channel, www.youtube.com/weldingandandt. So these are the two modes through which I share my knowledge. Friends, if you want to financially support me, you can do by joining my channel. You'll see a join button besides the subscribe button, and by joining you will have to pay a very small fees, and you can help me financially. If you want to connect me with on my social media, so here is my social media account. Now friends, let's start. There are many line types or types of lines which are used in the drawings. These are like object lines, hidden lines, center lines, dimension lines, then extension lines, section lines, cutting plane lines, break lines, phantom lines, and leaders and arrows lines. So all these lines are always given in drawings. Either it is a fabrication drawing or erection drawing, any part drawing. So everywhere you will see these lines. Today I'll explain the importance or significance of these lines so that you will be able to understand the fabrication drawings easily. So let's start the topic. See, many types of lines are used in the drawings, and these lines represent the various parts of the object. Now these lines, all these 10 lines, are collectively known as the alphabet of lines. So in drawing terms, in engineering drawing terms, these lines are collectively called as alphabet of lines. So we'll start with the first, that is object line. Object line is one of the very basic and fundamental line, and it is shown in this way. It's a thick and solid line. So here you can see this line is thick and solid line. So this line actually show the visible edges. All the visible edges are shown by the object lines, the corners and the surfaces of a part. So these are the things which object line shows. Secondly, if you have an intersection, so the intersection surfaces or the corners are also shown by the object line. And if you have a cylinder, then the extent of that cylinder is also shown by the object line. So here, with the help of this example, we will understand the basics of drawings as well as the importance of object lines. So here you have a three-dimensional view of an object. Now from the top side there will be a top view, from front side there will be another view, that is the front view, and from this side the side view will be different. So these are the three views, and how the object line has been presented and how these views are written in the drawings, that also you will understand. So this is a very basic video and you will understand everything. First let me erase these marks so that it will be easier for you. So we will start with the top view. So from top view, what are the parts which will be visible? So from top side, this square box will be visible from the top side. I'll write this as part 1. Then from the top side, this part will be visible. From the top side, this part will be visible. I'll write it as 2. And finally, this part will also be visible from the top side. I'll write it as 3, part 1, 2, 3. So this one is the part 1, this one is the 2, and this one is part 3. So these three parts will be visible. Now the edges of these parts are given by a object line. So this is a thick solid line through which the objects has been shown. Secondly, the intersection or the corners also has been drawn by the object line. So this is how the top view has been given with the help of the object line. Now we'll understand the side view. So let me erase this annotations. I'm erasing this so that no confusion will be created. If somebody is having any difficulty in understanding the top view, side view or front view, they will also be that will also be cleared in this video. Now we'll see the front side. So from front side, what are the parts that will be visible? So from front side, this part will be visible or this side will be visible. I'll write it as number 1. Then this, sorry. Let me use the eraser once again. Now from the front side, this part 1 will be visible. Then this part of the object will be visible from the front side. I'll write it as part 2. And finally, this part of this object will also be visible from the front side. I'll write it as part 3. So these 3 parts of this object will be visible. Here also this one is the part 1, this one is the part 2 and this one is the part 3. So the edges of these parts has been shown by the object line. So these are the edges which has been shown by the object line, and the intersection and the corners, intersection or the corners also has been represented by the object line. So this is how the front view will look. Now we'll see the side view. So before showing the side view, I'll erase these things so that no confusion will be created. So from this side, what will be visible? From this side we can see this part of this object. So this part of this object will be visible. Then this part of the object will be visible from the front side. So I'll write this part as 1 and this part as 2. So here part 1 you can see, and this one is the part 2. So all the edges, corners and intersection has been drawn by the object line. So you will also understand the top view, front view and side view, and you will also understand the object line. Here also I have a second example. So we have this part. So what are the things which will be visible if you watch from this side? So if you watch from this side, this entire part will be completely visible. This entire part will be completely visible since this is 3D. So here this entire outline has been given by a thick solid line. These are the visual parts. If you will watch, so if you will watch from the front side, means from this side, all these things will be visible. This outline will be visible. This has gone extra. Okay, you will be able to understand. So these things will be visible. Secondly, you have these circles. These circles will also be visible. So here these circles are visible. Here this circle is visible. This circle is visible. Now this main circle, this point will also be visible, and this one is the curved or tapered side. So this corner will also be visible, and the second corner, the second edge will also be visible. So here they have shown the opening of the circle, then this part and the tapered portion. So all these things are, again here this one is also the curve and the circle. So this is also shown. This is the taper part and this is the circle part. So this is how the object line is shown. Now you see the hidden lines. Sometimes there will be some part which is important for the fabricator, or which is important for the one who is reading the drawing, but since that is hidden behind the surface, hence to show those surface we use hidden lines. If that part is hidden behind the surface, so to show those parts you can use this hidden line. Basically this also shows the edge of the line which are hidden, so you use thick line but dash. You can see the equal dimension dash here, equal dimension dash line will be used. So this is the hidden line. This line represents the part which are hidden behind the surface of the object. Now hidden lines show the edges and contours, that is surface, which cannot be seen because they are hidden. Since they are hidden, but that is important, you have to show, so you'll use hidden lines. So here from this example we'll see this is a three-dimensional item. Just a second. So this is a three-dimensional view of an object. So from front side or this side, if you'll watch what are the parts you'll see of this object, so you'll be able to see this corner, and you'll be able to see this part of this object from the front view. Oh, ho, ho, ho. I'll write this part as 1 and this part as 2. So this one is the part 1 and this one is the part 2. So from this side, these two parts will be visible. Similarly, you have a circle also. So this circle will also be visible and it will be given by a solid line, that is this circle. Now, here the hole, this hole is also important, but since this hole cannot be seen from this view, for this hole you need to show a top view, but this hole is important, hence in this view also if you want to show this hole, so you will use a hidden line. So this hidden line is showing that hole because that is important. Now center lines. So this center line, in center line dash lines are used, one big dash line, one big line, then one small. Big and small line is used for showing the center. So center line represents the center point of the circle and arc. It also represents the center point of any round or symmetrical object. It also shows the center point of the holes or any irregular curves and bolts. So it shows the center of almost everything. Here we'll take the previous example itself. So from this view you have one circle. So to show the circle, here the designer has used this center line, one big line, then one small line, then big line. Similarly here also, for this also the designer has shown the center of this hole from this center line. Now dimension lines and extensions. Friends, the dimension is very important in drawings. If you have to show a fabrication drawing, the dimensions are very important. So to show the dimension, one dimension line is used and extension lines can also be used for the dimension lines. So why extension line is can also be used with dimension line, that I'll explain. Here you'll see the dimension line is both side you will have a arrow in dimension line, and the extension line is a solid line. So between this solid line a dimension line can be used. See, dimension lines show the size or length of the object. If it's a hole, it will show the diameter of the hole. If it's a rectangular box, it will show the length, breadth, everything. All the dimension can be shown by the dimension line. The ends of the dimension line touch the object being measured, or the extension line extending from the object being measured. And the so here you can see the ends of the dimension line touch the object being measured, or the extension line. If there is extension line used, so the extending line from the object being measured. Now extension lines extend from an object to locate the points being dimension. So extension line is nothing but it's a it gives a view from which the this line has been extended, from the portion it has been extended. From this diagram you can see here you have hole 1 and here you have hole 2. Now if you want to see the distance of this hole 1 to 2, how will you see? So from hole 1 to 2 you will draw two extension line. From this center one extension line has been used, and from hole to center another extension line has been used. So this is showing that it's a distance between the center line of these two holes, and for dimensional showing the dimension, this arrow has been used. This arrow or the dimension line has been used, and finally the dimension has been given. Here also from this example, if you want to see the distance from this hole to this hole, first two extension line has been used. Here one extension line, here second extension line, and between these extension line the dimension line has been given and the dimension has been given. From this hole to this hole also two extension lines has been given. This one is first extension line, this one is the second extension line. Second extension line is small, and between these extension lines the dimension line is given. From the center of this hole to edge also two extension line has been used, and between the extension line one dimension line has been given and that dimension has been shown. Now we'll read the section lines and the cutting plane lines. Sorry, it is not pipe, it is lines. I have wrongly written it as pipes. It is cutting plane lines. So cutting plane lines, these lines are used to reveal the details of internal parts. So if you have to reveal some details of the internal part, you will have to show through a cutting plane line. And why these details are revealed? Because it cannot be shown with the hidden lines. So from hidden lines the hidden edges can be shown, but if you want to reveal the internal parts, so for internal parts cutting plane line has to be used. It is purely an imaginary cut. It is purely an imaginary cut, and this is the cutting plane line. Now a section line is also used. So after cutting plane line you have to show the surface, the internal surface. So to show the internal surface that has been imaginarily cut away with a cutting plane line, you use the section line. So different types of patterns are used in section line, which used to show different type of materials. Here you see for steel this type of section lines are used. For copper or brass this type of section lines are used. For lead this type of section line is used, and for cast iron or for any other general purpose this type of section lines are used. These are mostly diagonal type of lines. So consider one part. This is one part, and if you want to know the portion over here, the internal portion of here, if you want to show this through the drawing, so what you will do, you will give a cutting plane line at this portion, or you write here AA, that is section A and section A, and here you will give the detail of this section, that is this part is the solid part and this part is the solid part, and between these parts there is a gap, and then again this part. So this is how you can show. We'll take another example. Here another example, two sections have been taken. Section AA from this slot and section BB from this hole. And how it will look? So if you see the section A, this part is the solid part and it is shown with the this drawing, and again then you have the slot part, that is hollow section, slot part, and then finally you have this solid part. Similarly here also, this is the circle part and this is the metal part. So from this pattern, see, from this pattern you will come to a conclusion that this item is steel. Why? Because steel is shown by these diagonal lines. We'll take another example. This is a circle and you are taking and cutting plain line from here. So from here, this will look like this. This one is the hollow part, that is center, and this one is the solid part, that is the steel. So this is a steel pipe hollow. Now break lines. Usually this break line is used to shorten or to reduce the size of a part. These lines are used to show that the part has been shortened to reduce its size on the drawing. This is often done when a long uniform object needs to be shortened to fit the drawing page. Basically the drawing page is small enough and the part length is very long, so for that you need break lines. There are two types of break lines, long break line and short break line. Whenever a break line is used, one can assume that the section removed from the part is identical to the portions shown on either side of the break. That is, here this part has been shown through a break line because it was a longer part. Here you have the break line. Now the section that has been cut, that is this section and this section, will have the identical portion. Matlab these parts are very identical, you can assume that. So here this is the long break line and this is the short break line. This long break line will be a zigzag type here, and the short break line will be a freehand line. Now you see the phantom lines. Now sometimes what happens, you have a moving part. So that moving part, the alternate positions of the moving parts can be shown by a phantom line, and the positions of the related or adjacent part you have to show. If you have to show the adjacent part, that is not details of not that adjacent part is not in the drawing, but if you have to show some adjacent part, that also you can show through a phantom line. So basically phantom line look like this: one big dash, then two small line. See here, one big line, then two small line are used. Again one big line, two small line. Here again big line, two small lines. So that is how it is different from the center line. In center line, one big small lines are there, but in phantom line, one big line will be there, then two small, one big, two small. Here you can see this piston. This is the moving part. So here one position is given and here the second position is given, and this position has been shown through a phantom line. Sorry, let me take the eraser. So this has been shown through a okay, no problem, you will understand it. So this has been shown through a phantom line. Here you can see one big dash, then two small dash, or one big line or two small line. Dash will be appropriate word. So one big dash, two small dash. This is how this center line has this phantom line has been shown. And now you can see the center line also: big, small, big, small, big, small. So this is the center line and this is the phantom line. Now here you have one column, but this drawing is of the girder. So this is the girder which has been shown in the drawing, but the position is also designer has to show. Then what he will use, he will show the column with a phantom line and the girder with the help of the object line. So this column has been shown through the phantom line because this column is adjacent to the girder and it has to be shown. That is why this phantom line has been used. Now finally, arrows and leader lines. So friends, if you have to give some additional information, some notes, some dimensional notes, some material specification and process notes, and then then in that case you have to use arrows and leader lines. These lines are normally drawn with an arrow head at one end. They are bent or angled at the start but should always end horizontal at the notation. Okay. Now see, here four arrow and leader lines are given. Here, here, then here, then here. Why this has been given? To give some special notes. Here you can see the arrow line, then this leader line. Horizontal one is the leader. So this arrow, and with the help of this arrow and leader line, you can give some special notes, like this is a flat bar 3 mm thick. Here this arrow and leader line has been shown that there are two holes. Dimension is 8 mm and two holes. So some special notes, for special notes this has been used. Again here the material specification has been shown that this is a copper plate. Now you see, for material specification you will use a dot, not arrow. Here you will see the arrow, but for material specification you will use a dot. Again here you see a arrow and leader line, that is the radius of 20 mm it has shown for this arc. So friends, with this we have come to an end of this chapter. Thank you very much.